Students, welcome back once again. So this is second video on the topic that is industrial and power electronics and the seventh part of the exam series that is lateral entry for diploma students. So as we are continuing last series, we have seen about the other aspects of industrial power electronics, mainly power electronics. And we have seen we have studied about the semiconductor components, what are used, and the circuits, basic things about this thing. Here also we'll discuss about the same in further. So first topic we will be discussing is motor driver and controls. Okay. So when we talk about motor drivers and control, please remember we specially refer a VFD, that is variable frequency drivers. What is variable frequency driver? In a simple terminology, because simple words, I will be telling you all the things and all. So converts fixed AC to variable AC, fixed AC to variable AC. Control speed, torque of an AC. Please remember, it's a AC. Torque of what? Motors. So what are the main components of this? The components are rectifier, then you have DC bus, then inverter, then motor. From rectification, rectification is done first, then it will go to the DC bus, then it will go invert again, it will be changed to AC, and then it will drive the motor. So here you can see where we use it. This is one of the circuits. These are the two basic circuits. The bottom circuit is for projects like you do for your robotic wheel drivers or some sort of drivers or arm drivers and all that. There you use these type of drivers, boards. And this is your example for your electric vehicle where the motors are driven by AC motors or BLDC motors are driven by the same principle, that is VFD principle. So control technique is controls V by F control is a simple technique. There is another technique that is vector control, that is very precise technique. Direct torque control is fast technique. Application, where do we use it? Pump, fan, compressor, conveyors, belts, elevator, robotics, CNC machine. So these are the use for your VFD. Next chapter is, or next topic is SMPS, that is switch mode power supply, which converts AC to DC. It's a converter, please remember, which converts AC to DC. To regulate, stabilize DC voltage. Both the things will take place, conversion as well as power regulation, it will take place. Where it is used? It is almost used in all the power supply section of your appliances, machineries, medical equipment. So this part is very, very important. You should learn more about SMPS and all. So here I have shown few of the circuits like a mobile phone charger, TVs, desktop computer, and a block diagram. Okay, now we will study what is SMPS. What do you mean by SMPS and how does it work? Okay, this is used for DC to DC conversion. This works on the principle of switching regulation. The SMPS system is highly reliable, efficient, noiseless, uncompact because the switching is done at very high rate in the order of several kilohertz and megahertz. This is a very important point. You have to remember the switching is done. Since the name it is there, switch mode power supply, switching has to be there. That is on and off switching has to be there. That will be very, very fast. It will be in kilohertz to megahertz. The SMPS regulator are used to provide regulated voltage for various equipments like PC, CFL, TV, and so on. I told you nowadays everywhere the SMPS circuits are used. Okay. So next topic is thermal management and production. Okay, so this is also very important. Why? Because thermal is also a very important subject of your power supply. Why? Because we use a component which gets heated up. So critical design aspects are heat removal. That is the main work of the thermal management. Heat sinks, that is aluminum plates and different shapes and size, they are used. Fans are also used. Liquid cooling are also used. And paste like heat sink paste, we call it as, that is also used. So let's go to the next this thing, that is the protection circuit. So protection circuit, over current and over voltage. When we talk about power electronics, then over current and over voltage is very well. That is dV by dt and di by dt snubbers, we call it as. Okay, that is short circuit protection. We call it as this circuit as short circuit protection. EMI oblique EMC. Consideration, proper filtering, shielding, PCB layout optimization. Okay, so these are comes under your EMI and EMC consideration. You can study about EMI and EMC. That is, you can see here in the right hand side, complete thyristor protection circuit. We have made what is a EMI circuit, inductor, capacitor, resistor will be placed in there, and it will be working like a EMI circuit. Okay. Then you have reliable factors, that is junction temperature limit, thermal cycling, and vibration resistance. These are the important part you have to remember in this particular topic. Right. Now we will go for one more topic, that is optoelectronic devices. Okay. Optoelectronic devices. What is it? Electronic component that convert light into electrical signals and signals to light energy using semiconductors to emit, detect, or control light. Vice versa. Both things can be done. Light to energy, energy to light. Both the conversion. We study optoelectronic devices. Example, light emitters, example, are converting electricity to light, that is LED lights, laser diode, scanner, DVD players. These are the laser diode. These are the simple example. Light detector, photo detector converts light to electricity, right? What is photo detector? In remotes, in our TV side, that is the photo detector. Okay, that is also, it will convert one type of a light into electricity. So photodiodes, transistors we use, light sensor, where we use it, light sensors, cameras and all, it is used in there, photodiodes and photo transistors. Solar cell, this is also very important. Photovoltaic cell, we call it as generate electrical forms from sunlight. That is also converting one type of energy to the another one. LDR depends resistor, that is light dependent resistor. We do a lot of practicals with it. That is light dependent resistor. Ambient light sensors, light modulator controllers. What are light modulator controllers? Optical fibers transmit light signal over distance. Okay, and optocouplers isolate electrical circuit using light. So these are the parts that is transmit optical fibers or optocoupler. Basically, optocoupler is a part. Okay, that is a part. It's a compact part where it will isolate electrical circuit using light. All right, so let's come to the next one. One more thing important we have to learn, that is linear variable differential transformer, LVDT we call it as that. So you should have an idea about LVDT also. So LVDT, linear variable differential transformers, are precision sensors, right? It is mostly used in very big industrial sensors circuits and all, to across many industries to measure linear displacement, position, and vibration with high accuracy finding. Like example, you have use in an aerospace, flight controls, landing gears, industrial automation, robotics, CNC, valve controls. So mainly in industry, this will be used, the higher industry it will be used. Let it be aviation industry, let it be manufacturing industry. So automotive, suspension, throttle, power generation, turbines, and in medical device, MRI, surgical tools, and material testing, stress and strain both. So you can see on the right hand side, the circuit is there. So there is a core which will be vibrating. There are in between two coils, primary and secondary. There is a core which will be ferromagnetic core, we call it as, and there will be in between the two bobbins, the plates, and it will be vibration, and that vibration will be produced, and it will be counted or taken as for some work. So finally, you can see here, power electronics, a verb. A very good, this thing has been said that power electronics is the invisible backbone of modern electrification, enabling sustainable energy future. So you have to keep it in mind. Now let's go to choose the most appropriate answer for each of the question what we have studied. So in this, we will discuss, I'll give you some important questions so that you prepare for your examination also. So first question, MPPT is a primary used in what? Whenever you heard this word, it is a solar inverter. Please remember, MPPT is a type of a solar inverter. Not UPS, not welding machine, no, neither it is a motor driver. Question number 2, which is a fax device for voltage regulation? SATCOM is the correct answer. Okay, so it's a fact device. So previously, in the last video, that is the 6th video, I've discussed about SATCOM. So you can refer to that video also. So third question is space vector PWM, that is pulse width modulation, is commonly used in 3-phase inverters. Okay, PWM, that is space vector, we call it as. It is used in 3-phase inverters. Next question, that is fourth question. A cycloconverter provides AC to DC with variable frequency. Probably this we have already taken up in the last video also. So cycloconverter provides AC to AC with variable frequency. Next question, that is question number 5. In a 3-phase full bridge inverter, each switch conduct for 180 degree full bridge, right? It's a full bridge. That means compulsory it has to be 180 degrees. All right. So now we will go to the 6th one. The primary purpose of snubber circuit is to increase efficiency, limit dV by dt and di by dt. This is the correct answer. That is limit dV oblique or divided by dt and di by dt. This is the correct answer for the question number 6. Seventh, DFIG stands for what? It stands for double fed induction generator. Question number 8, the main challenge in EV traction inverter design is all of the above. That means low power density, high efficiency requirement, and low cost. All the three. That is A, B, and C. All the answers are correct one. Let's go to the ninth one. Which cooling method offers the highest heat transfer coefficient for high density power conversion? So liquid coolant is said to be the good one. Okay. So liquid cooling is the best one. Let's see. Let's go to the question number 10. That is power semiconductor design. The primary parameter determining maximum allowable power dissipation is junction temperature. We call it as a junction temperature. Let's go to the question number 11. A DC-DC converter that provides both step-up and step-down capability without transformer is isolated is typically a buck boost converter. We call it as a buck boost converter. Out of this, you have to understand. Okay, last question. The fundamental principle of a SMPS differ from a linear regulator primarily because it is operate transistor in switching mode rather than linear mode. This is a very important question. Please remember the question number 12 is very important, operate translator. So you can refer to my other videos where I've given you about the power supply, especially the SMPS. I hope this will give you a little idea for your preparation and any comments, or please remember, if you need any help related to studies and questions, please let me know so that I will make videos and I can share it with you. Thanks for watching.